All right, I should be on now.
Yeah, it says recording for me.
Okay, good. It must be just lagging a little bit. So 4-6 weeks, I think, is always a harder 6 weeks, and I see grades drop tremendously during the 4-6 weeks. And this is going out to everybody, not just you guys that are on, but some of our grades are not the best in the world. And so with 4-6 weeks being a harder 6 weeks, some of us really need to get in gear a little bit better and do more work and do our practice better and retake tests and things like that. So please put forth the effort. If you have questions, come ask me. I will be more than happy to help you, but you got to come and ask. What we're starting this time is called slope. Oh, let me share my screen or y'all will not be able to see me. Can you guys see my CAMI worksheet?
Yep.
Yeah. All right. I just wanted to make sure it was coming up. Okay. So what we're going to talk about is called slope. Now, slope is very important in algebra and making lines and writing equations. All right. Slope tells us how steep a line is. Now, if you think about skiers, okay, perfect weather today because of the snow outside, but when you're beginning to learn how to ski, your slope is very small, okay? So that way, if the skier is starting at the top, okay, they have a slope to go down. Now, as skiers get better, they like a more intense slope, which means it's steeper. Why would they like a steeper slope?
More momentum.
More momentum. They're going to get going faster, okay? That's where they, if you see them, they're jumping and all kinds of things. And so they like a steeper slope. That is what we're talking about when we talk about lines. Now, the first thing we're going to actually talk about is we're going to be looking at tables, okay? So I'm going to make a table here. We're going to have our X and Y values. All right, and then I'm going to give us some numbers. Let's just start out very basic. Okay, so I have this table, and I want you to basically come up with the equation for these points. Now, yes, it's in a table, but I can actually think about this as being ordered pairs, okay, which means I can put my X value first and my Y value second. I'm going to put them in an ordered pair. Okay. The other thing I can do is I could actually graph it. So I'm just going to freehandedly graph this. Okay. So I could put points based on these points here on a graph. And now I have a line. Well, I was going to draw a line, but my finger's going off the thing. Okay, so I could have a line. Well, I don't want to have to convert to all three things before I make myself know that that's a line. So what we have two things here. We have one, which is called an additive relationship. So what operation do you think we're going to use when I say additive relationship?
Addition.
Addition. And the other one would be multiplicative relationship. So what do you think of when I say multiplicative?
Multiply.
Multiply. So our relation here is going to be either add or multiply. Now, how am I going to do a subtract or a divide? Anybody have a thought on that? Anybody have a thought? Can I rewrite a subtract as an addition statement?
Yeah.
Yes, because if I had X minus 4, I could rewrite that as X plus negative 4. Is that correct? Those two statements are the same thing. Same thing with multiply and divide. If I had something, if I had a multiply and a divide, if I said 2x, or here I said x divided by 3, I could rewrite that division over here as 1/3 x. That is the same as x divided by 3. And here's why. You may have trouble with that one. If you think of multiplying this, okay, I can make x a fraction by putting it over 1. And then if I multiply my two top numbers, and then I multiply my two bottom numbers, I still get x divided by 3, correct?
Yeah.
So that's why that's the same as 1/3 times x. So you can rewrite that division statement as a multiply statement. Okay? Now, I'm going to scroll back down here and I'm going to make that table again. So what you're going to get today is you're going to get some tables. And first of all, you're going to have to tell me, is this an additive relationship or a multiplicative relationship? So what you want to think in your head, so I'm going to write down what I'm thinking. You don't have to write this down. 1, you're going to always start with your x plus what would equal y. So 1 plus what would give me 4?
3.
3. Okay, so now I need to make sure that that statement is going to be true for every other point in that chart. So if I took 2 and added 3, would I get 5?
Yes.
Yes. What about 3 plus 3? Would I get 6?
Yes.
Yes. So my statement here, okay, so I'll always want you to write it back as y equals x plus, and we're going to use a as the variable that's going to be changing, okay? So y and x are going to stay the same. So y is equal to x plus, and what did I add every time?
3.
I added a 3. So that is my equation for that table. Did everybody see what I did?
Yes.
Okay. All right. So let's look at another table. Okay. I kind of started out with the same one. We had 1 and 4. So the first thing you might think is 1 plus what equals 4? And we already said that that was 3. But is that going to hold true for number 2? So
No.
2 times 3 is 6. So that didn't work. So I kind of have to go back to my original statement and think, okay, well, is there anything different I can add? No, because we know they all have the same answer when I plug in. So let's think of multiplying. So 1 times what would give me 4?
4.
4. Now, is that going to work for all these? 2 times 4, is that going to give me 8?
Yes.
3 times 4, is that going to give me 12?
Yes.
Okay, so again, I'm going to write my statement as y equals ax. Now, again, a is the coefficient that's going to be changing, and we said a was 4. So we're just going to put y equals 4x. Did everybody see the difference between the adding and the multiplying? Steps are the same, though.
Yeah.
Okay. All right. Let's do a couple more little tables.
It's looking easy so far.
I know this is not that difficult.
So
Now,
far.
unfortunately, these do become harder in Algebra 1 because not only will I get y equals 4x, then I become with equations that says stuff like y equals 4x plus 8. So not only am I multiplying each time, I'm also adding something as well. So that does become a little harder. But this year is all you have to know is the additive and multiplicative relationship. All right. So we're going to get some higher numbers that shouldn't make it that hard for you. Okay. I always start with addition first. I mean, you don't have to. You can think of multiplying first if you want to, but I kind of always start with addition first. So if I'm thinking, again, this is what I'm thinking.
Plus 13.
Okay. 14 plus what would give me 27?
2 plus 13.
13.
13.
13.
Okay. So now I want to see if that's going to hold true for every one of these. What's 72 plus 13?
85.
85. That's what the chart told me I should have had, so I'm good so far. What about 35 plus 13?
48.
48. 78 plus 13?
91.
91. And 21 plus 13?
34.
34. So what's my equation going to be? Y
13.
equals X plus
13.
13. And that's my equation. I'm done with that. Okay. So there's not a lot of work to show tonight. This is my thinking, what's going on in my head. Okay. So really, you're just going to come up with this right here. Okay. So you don't have to do a whole lot of work on your paper today. All right. So let's look at this one.
No, we're going to be minus
How did you know that?
because the second number is shorter than the first.
Correct. Say that again to make sure everybody heard that. We're subtracting because.
The second number is shorter than the first.
Very good. So we know we're going to subtract this time. And I'm okay with you thinking in that subtract method, okay, for us to do this. So what's 62 minus what is going to give me 58?
4.
4. What's 92 minus 4?
4. Oh, no. 88.
88. What's 102 minus 4?
98.
98.
And what's 38 minus 4?
34.
34. So what's my equation going to look like? Y equals
X subtract 4.
Yes. Now, if they really wanted to force you back to add, we can. I am good with this right here. But remember, this is still called additive relationship because I can rewrite that because they mean the same thing, okay?
Nice.
But I like the X minus 4 is what I like, okay?
All right.
All right. Another one?
Yep.
Another one bites at us.
Sure.
I know the answer.
Shut
What do
up,
you
Mario.
think we're going to be doing?
1 second.
It'd be Y equals X times 4.
Very good. Tell me how you got that.
10 times 4 is 40. 2 times 8 is, or 2 times 4. I can't speak right.
All right. So when he first looked at it, okay, did you try and add or did you automatically see the multiplying?
Automatically see the multiplication.
Okay. And sometimes you will and sometimes you won't. Okay. So that was really good that he picked up on that one.
Times tables.
I know. I've got to write these down though. That he saw that we had a pattern going that for all my X's, we're just multiplying by 4. Now, what I did hear you say, though, was Y equals X times 4. Remember, 4 is your coefficient, so 4 needs to be in front of that variable, okay? Because remember, your coefficient and variable are always multiplied. So we like our coefficient in front of the variable, okay? Now, not when we're adding and subtracting, but only when we're multiplying, okay? Everybody good with that one?
Indeed.
Yep.
Okay. So get another one.
I have a question.
Yes.
How you started the meet at 9:03, does that mean you'll end it at 9:33 or just end it at 9:30?
Actually, just whenever I get done.
Oh.
And this is probably going to be my last one unless you guys have questions.
This one's dividing. I can tell you.
How do you know this one's dividing?
Because the lowest number is the second one.
Yes, because my y value is smaller. So we know we're dividing on this one. Now, what am I going to be dividing by?
10.
10.
I'm going to be dividing by 10. Does everybody see that?
Yep.
Okay. So I'm not going to finish those out, but that is true. I am dividing by 10. Now, so right here I have y equals x divided by 10. Now remember, I don't like that division here. So what else could I do? I can rewrite it by multiply by doing what? What's my coefficient in? I'm sorry, what?
Minus.
Nope, I can't change from divide to minus.
Put x over 1 and 10 over 1 and multiply.
Okay, we're going backwards right now. That was good. So what's my coefficient in front of x? 1, right? So what I want to do is I want to pull this coefficient away from x. So I want to put y equals 1 over 10 times x. Everybody see what I did there?
Yep.
Super easy.
Yeah, it's not that difficult, but sometimes we get in a panic when we see this and we think, oh my gosh, I don't know how to write that. Well, first of all, find your coefficient of x. Okay, sometimes it'll be 1, sometimes it might be a different number. Okay, and as all I did was I pulled it out in front so it looks like a fraction times x.
Why would it sometimes be a different number than 1?
Probably from our tables right now, it's not going to be, but when they get next year, what they might get is something like this as a table. So they may get something like this. Okay. Now we can't do, because if we add 3, that doesn't hold true here, right? Because the next one was adding 4. If I look at a multiply, okay, I can multiply. Sorry, I'm trying it right here. It goes. I can multiply by 2. No, I'm sorry. I can multiply here by 5 over 2, and that would give me 5.
Oh,
but
good.
when I do this one and I multiply by 5 over 2, I'm not going to get 7. So when they are going to see a different number here, it's going to be because I'm multiplying by a different number. Okay, so it might be something like, if I was to write my equation, it might be something like 2 over 5x. So if I looked at that table, my points might be, if that was 1, this would be 2/5. My second would be 4/5. Okay, so they become a little bit harder. And so sometimes that's why that coefficient might not have a 1 on the top.
Okay,
But
we'll
we're
get
not
into that
going to
later.
see that right now. But I just want you to know that it's not, that number may not always be a 1 in front of that
That'd
x.
be like an algebra 1 or 2.
That's going to be an algebra 1 thing. So that will be next year for you guys.
Oh,
God, that's in
great.
high school and I don't want
But
to
it's
think
not
about
that
it.
bad. If you get this baseline right now, then next year it just adds a little more into it. So it's not that bad, I promise. Okay?
Okay.
These are the types you're going to see today, which is those first few that we did with just add, subtract, multiply, and divide, just basic numbers. Okay?
Would we be doing this when we come in tomorrow? If we come in tomorrow?
We'll probably be doing another short kind of thing of it, but we're probably going to be moving on because slope has 4 different ways that we can find slope.
Learn the ways of the slope.
I know.
Nope.
And so we'll talk about this a little bit more tomorrow, but we'll probably start something new as well on top of that, okay?
What's the
Okay.
new thing, may I please ask?
Probably graphing.
Oh.
Because we can find slope by ordered pairs, by a table, by graphing, or by an equation. So we might do an equation tomorrow. That's fairly easy.
equation.
Yeah, I thought this was fairly easy. So, all right. So I'm going to attach your homework. It's not attached yet. So probably within the
How
next
many
5
questions
minutes,
are on the homework?
it's going to be 2 pages,
Nice
like
picture.
two assignments, but they're going to be fairly quickly. Okay. One will ask you to tell me if it's additive or multiplicative, and then to write the equation. And I think the other one just asked you to write the equation. So it
Alright.
shouldn't take you 10,
Oh,
20
they're
minutes.
both
So you
the
may
same.
be able to get this done before you go to Miss Perkins' room. Okay.
Okay.
Good enough for me.
All righty. I'm going to hop off. If you guys have questions, just message me later and I don't care to help. Okay.
Have fun.
All right.
Happy
Thank
New
you guys.
Bye.
Bye.
See ya.
Oh my God.
Rain. Bye.
Yeah.